A very good morning to Dr. Mahmood and my fellow friends. We are from Group 2, will be presenting about hydraulic leaf. Next is table of content, which contains 7 things that are about us: introduction to the hydraulic lift system, the design and components of the system, the operation and how the system works. Fifth is how fluid mechanics principle applied in the system. Sixth is conclusion, and lastly, minute meeting. I myself, Durgesh, Daryl, Farhan and Aris worked together to complete this report. Starting with the introduction to the system. A hydraulic lift is a mechanical that utilizes an incompressible fluid to operate a piston and elevate a load. This device is fundamental based on Pascal principle, which states that pressure change applied to a confined fluid is evenly transmitted through the fluid in the operation of a hydraulic lift. Hydraulic lifts serve diverse purposes, ranging from car maintenance operations to powering forklifts in warehouse logistics. Although these uses are diverse, every hydraulic system is built on identical fundamental principle. This is the example design of hydraulic lift. Moving on to the components of hydraulic lift system. There are mainly 6 important components in hydraulic lift system. Starting with hydraulic circuit. This circuit includes valves, pressure switch and flow controllers, and all of which will collaborate to ensure safe and effective movement of hydraulic actuators to lift. Next is hydraulic pump, which will often rotary or reciprocatingly in design, converts mechanical power from an electrical motor or internal combustion engine into a steady flow hydraulic energy. Third is hydraulic motor. The hydraulic motor serves an essential actuator or in hydraulic equipment, converting fluid pressure and flow into rotationally force and torque. Moving on to hydraulic cylinder. It's called a linear actuator or RAM. Is a key converting hydraulic fluid pressure into powerful linear motion. Fifth is hydraulic piston, which operate within a cylinder under immense fluid pressure to produce precise linear displacement. And lastly is hydraulic fluids, which are silicone oil or glycerol ether, which plays a crucial role in a system efficiently, gives wear protection and heat dissipation for hydraulic lift and machine.
Okay, so now I'll proceed to explain about the operation or how the system of hydraulic lift works. So a hydraulic lift, it operates based on the Pascal law to magnify force. And in the hydraulic system, in the hydraulic lift, the force is applied at one point to an incompressible hydraulic fluid such as oil, usually is a high-grade oil, and it transfers through the pipe to a second force. So which means it transfers from input to output. Input is where we apply the force, and the output is where the force is magnified. Maybe magnified 2x, 3x, 4x. So when the force is applied in the input force, it's a small force. It creates a pressure that transmits uniformly throughout the hydraulic fluid to a larger force, which is the output force. So to calculate the force, input and output, it can be determined by pressure 1, pressure input, is equal to pressure 2, pressure output. So pressure is equals to F over A, force divided by area. So force F over A equals to F over A. So in the input, the force and the area will be a small value, where the output, the force and the area will be a bigger value than the input value. So with this formula, we can know that what is the output force for the what is the value of the output force. We determine value of input force and input area and also output area. And this is how usually hydraulic lift works. With a small value of force was being inserted by us, by users, and then through pressure it magnifies the force so that it can lift object that is heavier, like 30, 40 to 100 kg or even more, based on the hydraulic system, the oil.
Assalamualaikum, my name is Ali Shahmi, metric number AA230206. Today, I will explain how fluid mechanics principles are applied in hydraulic control system. First, what is hydraulic control system? It is a system that uses pressurized fluid to control movement of force. You can find it in machines like excavators, airplanes, and factory automation. The main principle behind the system is Pascal law. This law states that pressure applied to a confined fluid is transmitted equally in all directions. This means with a small force, we can produce a larger force at another point. This formula is P equal F over A, or pressure equal force divided by area. The key component in hydraulic system are a pump to generate fluid flow, valve to control the direction and pressure, actuators like cylinders to convert fluid power into motion, and lastly reservoir and pipes to store and move the fluid. Next is application. The system also follow basic fluid mechanics law like the conservation of energy and mass. This ensures the system runs smoothly and efficiently. Hydraulic systems are used in many areas, for example, in excavators to move the arm and bucket, in aircraft to operate landing gear, and lastly in factories to control machines and robots. In conclusion, hydraulic control systems are a great example of how fluid mechanics help us control large forces easily and safely using fluid power. That's all from me. Thank you.
Finally, to conclude our presentation, the hydraulic lift is a strong example of how Pascal law is applied in a real-world mechanical system. It proves that by using fluid pressure, we can lift the heavy loads, efficiency and with minimal input force. In a hydraulic lift, all the components including the hydraulic pump, piston, cylinder, valve and the fluid itself are designed to work together to transfer force smoothly and reliably. This coordination allows the system to perform consistent and safe lifting operation even in demanding environment. One of the key principles we observe is force multiplication. By applying force on a smaller piston, pressure is transmitted through the fluid to a larger piston, which results in a greater lifting force. This concept is widely used in automatic lift, construction equipment, and aircraft platform, where large weights need to be moved with precision. And throughout this project, we have gained a much better understanding of how fluid mechanics principles such as pressure transmission, surface area ratio, and conservation of energy are applied in actual mechanical system. For example, while the force is increased, the movement distance of the output piston is reduced, keeping energy balance. This topic also highlights how choosing the right hydraulic fluid is essential. The fluid must be incompressible, stable under pressure, and resistant to temperature change to maintain the system performance and safety. Lastly, in conclusion, the hydraulic lift is not only a practical application of physics, but also a great example of how theory and engineering come together to solve a real-world problem efficiently.